In this video, we'll be learning how to solve a system of equations. Specifically, we're going to be looking at the only type of regular equations that we've worked with and have graphed in the past, linear equations. Now, quite literally, the solution for a system of linear equations, if you were to graph the line for two equations, we're looking for the place where those two intersect. So our answer is going to be an ordered pair, parentheses, x comma y, close parentheses, for every problem that we look at in this video. So the first method we're going to look at is substitution as a way of solving systems of equations. And this first equation, I've already got it set up where we have the first one solved for y and the second one solved for y. So in both equations we can replace the letter y with the other statement. We can say that 7x plus 10 equals 9x plus 38. And what we have now is a single equation where the variable appears on both sides. So the first thing we need to do now is to decide what side are we going to put the variable on. You can put it onto the left or you can put it onto the right. I'm going to choose to put it onto the right simply because by subtracting 7 from 9, I'm keeping the coefficient of x positive, and that's just a preference that I happen to have. So 10 equals 2x plus 38. We'll subtract 38 from both sides, and we have negative 28 equals 2x. Divide both sides by 2, and x equals negative 14. So we have half of an ordered pair now. We know the x, but we still don't know the y. At this point, we can go ahead and just plug negative 14 into one of these equations to get an answer. Let's do the top one. We're saying that, or I'll change colors here, make it a little bit different. We're saying that y equals 7 times negative 14 plus 10. 7 times negative 14 is going to be negative 98, and we add 10, and when you subtract 98 from 10, we end up with the number negative 88. So I believe that the final answer for this is going to be the ordered pair negative 14, comma, negative 88. How are we going to check this answer? Well, it's a good thing we have another equation right here that has both an x and a y, and we can use that to make sure that we did it correctly. So let's put this all together. We're saying that negative 88 equals 9 times negative 14 plus 38. Now 9 times negative 14 is a negative 126. And we're saying that equals negative 88. And then the difference between 38 and 126 is an 88 of sorts. We're saying that negative 88 equals negative 88. So this ordered pair that we have written down up here is the correct answer. So let's take a look at another system of equations. And we're going to solve it the exact same way, but this time I don't already have one of the variables solved for. But we can remedy that very quickly. Look at the second equation. There is no coefficient except for a negative sign, or negative 1, in front of that y. So we're going to use that one as the one we're going to solve for a single variable. We'll begin by adding y to both sides so that we get 2x equals 6 plus y. And then to get y by itself, we'll then subtract 6. From both sides. We end up with 2x minus 6 equals y. Now that we have that, we can go ahead and substitute this value for the y that you see right here. We're going to say that 3x plus 4 times y, and y is now going to be equal to 2x minus 6, and that equals 31. First thing we'll do is use the distributive property to say that 3x plus 8x minus 24 is 31. Combine like terms. 3x plus 8x is 11x minus 24 equals 31. Add 24 to both sides. And we get 11x equals 55. When you divide both sides by 11, we find that x equals a positive 5. So we have one of our two answers for our ordered pair. Let's use the second equation because it's probably going to be the easiest one to work with right now. But we're going to say that 2 times 5 minus y equals 6. We're saying that 10 minus y equals 6. Subtract 10 from both sides. We're saying that negative y equals negative 4, which means a positive y is a positive 4. So we believe the answer to be the ordered pair 5, 4. Of course, the only way to be absolutely certain about that is to plug it in. We used this equation to find our second variable, so we'll use this equation to check to make sure we did it right. And in the interest of space, you can just rewind the video to see that, everything that I wrote down there again. But we're going to say that 3 times 5 plus 4 times 4 equals 31. That's 15 plus 16 equals 31. And you know what? It does. So this checks out. The answer is the ordered pair 5, 4. So we just did two problems using the substitution method for solving a system of equations. But there is another method that's available. Some people call it combination. I like to call it addition. All we need to do is add the two equations together a certain way, and we're going to be able to get the same answers that we did before. Now you'll notice this is the same equation as the first one, the same system of equations that we used the first time. But this go around, we're going to add the two equations together to get our answer. Now to do that, we need to be able to eliminate one of our variables. So I'm going to multiply this top equation by -1. That means everything in that top equation is going to be multiplied by -1. It's going to become negative y equals negative 7x minus 10. Everything went from positive to negative. And now that we've done that, we can add the two equations together. Y minus y is 0 equals 9x minus 7x, which is 2x, and 38 minus 10 is 28. Subtract 28 from both sides, and we get negative 28 equals 2x. Divide both sides by 2, and we find that x still equals 14. Now this time, well, we've already found one of the variables, and if we take a look back at how we solved this the first time, we still started by finding that x equaled 14. So if we just repeat what we already did, we'll be able to find very quickly that y, of course, has the same value as well. Now, in this slide, we're going back to the second equation that we did, and I think you'll find it a little bit more interesting because we're going to do more than just multiply by -1 to change one of the equations in order to eliminate one of our variables. We're going to multiply this second equation by 4. Why the number 4? I want you to look at the y variable and see what happens to it. The bottom equation is about to become 8x minus 4y equals 24. The top equation, we didn't do anything to it, so we'll leave it alone, and it'll be 3x plus 4y equals 31. Look at what happened to the y variables. We have a positive 4y and a negative 4y. So when you add the two together, they're going to cancel each other out, leaving only the variable x behind. And that's exactly what we want to have happen. 3 and 8 is 11. The y's cancel, and that equals 55. If you divide both sides by 11, we find that x, once again, equals 5. And if you plug that x back into either of the two equations, we'll get the same answer that we did before, that the ordered pair solution is 5, 4. And those are two methods that you can use to solve a system of equations.